So, good day everyone. Today we will present our work on laboratory exercise 2, which involves creating a web server using our ESP32 microcontroller. So, the ESP32 is a highly versatile microcontroller with integrated Wi-Fi and Bluetooth capabilities, making it a fantastic choice for IoT projects. So this project was a collaborative effort by our group and my team members with Engineer Alvin Arevalo and Engineer Hazel Solivio. So throughout this presentation, we will walk you through the process we followed to set up our web server. So let's begin by discussing the objectives of this laboratory exercise and the materials we used. So now these are the main objectives of our laboratory exercise. We have three main goals. First is to build a simple ESP32 web server using our Arduino software. Second is to design an ESP32 circuit that will be controlled by the ESP32 web server. So in order to create a physical circuit that could be controlled remote via the web server, so this included connecting sensors and actuators to our ESP32 and configuring them. Next is, or lastly, is to design an HTML and Arduino Core IDE program that will connect the server and the client. Now, to complete our main objectives, we use the following materials. So first is our breadboard, which served as the main foundation for our circuit. So next is ESP32 training kit. So this is the microcontroller that we will use. Next is the our LED. So visually represents the output. Then the resistor. So the resistors were used in the series with the LED to limit the current and to prevent the damage from our LED and ESP32. So next is the piezo buzzer. So the piezo buzzer was used to generate audible feedback in our projects. The jumper wires to make connections between the ESP32, the breadboard, and the various components. Then lastly is the laptop with installed Arduino Core IDE. So this software environment allowed us to write, compile, and upload our code to the ESP32. So these materials provided us with all the necessary tools to build and test our ESP32 web server project.
In case Arduino IDE was not installed on your device, you may visit www.arduino.cc/and/software to download the installer. Once downloaded, proceed with the installation process. To give you with the better visuals presentation of the project and how was the materials are connected. The materials required for this project include an ESP32 dev kit development board, two 5mm LEDs, two 220 ohms resistors, and connecting wires. Let's start by building the circuit. We'll connect two 5mm LEDs to the ESP32 as shown in the following schematic diagram. As you can see, one LED is connected to GPIO19 and the other to GPIO22. Both LEDs are connected through 220 ohms current limiting resistors and share a common ground connection. Here is the step-by-step assembly. Insert the ESP32 into the breadboard, connect the positive lead, longer leg, of the first LED to one end of a 220 ohms resistor, and the other end of the resistor to GPIO19. Connect the negative lead, shorter leg, of the LED to the ground, GND, pin on the ESP32. Connect the positive lead of the second LED to one end of the other 220 ohms resistor, and the other end of the resistor to GPIO22. Connect the negative lead of the LED to the same ground, GND, pin on the ESP32. Now, the circuit is assembled, and we are ready to program the ESP32 to control the LEDs through a web server. Stay tuned for the coding part. Here we provided with the code that creates the ESP32 web server. Copy the following code to your Arduino IDE, but don't upload it yet. You need to make some changes to make it work for you. You need to modify the following lines with your network credentials, SSID and password. The code is well commented on where you should make the changes. Now, you can upload the code and the web server will work straight away. Follow the next steps to upload code to the ESP32. Plug your ESP32 board in your computer. In the Arduino IDE, select your board in Tools a board. In our case, we're using the ESP32 DevKit board. After uploading the code, open the serial monitor at a baud rate of 115200. To access the web server, open your browser, paste the ESP32 IP address, and you'll see the following page. Now you can test if your web server is working properly. Click the buttons to control the LEDs. At the same time, you can take a look at the serial monitor to see what's going on in the background. Thank you for listening, everyone. Again, this is Engineer Alvin Arevalo, Engineer Cleo Andre Gomez and Engineer Hazel Solivio, presenting for the Laboratory Exercise 2.